Commercial flights lack parachutes. If a plane at 10,000 meters is about to explode, your only option to avoid being blown up is to jump. But after jumping, is there any chance of survival? And where would you aim to land? The femur, the strongest bone in the body, can endure up to 160 megapascals of pressure, not accounting for muscles and cartilage. A 60-kilogram person jumping straight down from a height of 1.7 meters without any cushioning. His neck would definitely break, not to mention falling from 10,000 meters. But the good news is, when you jump out of an airplane, it's not going to get faster or faster, because the faster you fall, the more air resistance you have. When you hit 54 meters per second, air resistance and gravity even out, stopping any further speed increase. This is known as terminal velocity. So, what if you hit the water at terminal velocity? Could you survive by entering with perfect diving form? Does that mean you could survive? Let's first look at which position is best for entering the water. The first option is headfirst, like a torpedo diving in. The second method involves clasping your hands above your head to minimize impact and shield your head. The third option is to keep your legs together and use the hardest part of them to break the water's surface, entering vertically. Which method seems more practical to you? Let's assume a person's cross-sectional area is a circle with a 0.2 meter radius. By applying the drag equation, we find that when a person hits the water at terminal velocity, the body faces a drag force of 200,000 newtons. Imagine trying to support a 20-ton iron block. Unless you've somehow become a superhero with extreme body modifications, an average human body just can't handle that kind of force. So, hitting the water at that speed, regardless of your position, makes survival very unlikely. So you might ask, if there's blood on the ground, how thick of blood does it take for a person to survive when the human body suddenly slows down? It can withstand an acceleration of 20 g, and we assume that the hardness and softness of the blood are appropriate when you fall into the blood at terminal velocity. You have to have at least 18 meters of blood to safely reduce your speed to zero. A thick layer of blood is uncommon, so tree branches might help slow your fall. On January 26, 1972, a plane exploded over the Czech Republic, and flight attendant Vesna Vulovic fell from a height of 10,000 meters. Due to the dense branches above the snow, she landed with almost all of her bones broken, but she survived. If you fall from a great height, aim for tree branches, snow, or haystacks, anything that can slow you down, and absolutely avoid water. Douglas Adams, the author of The Hitchhiker's Guide to the Galaxy and Doctor Who, once said, "It's not the fall that kills you, but if you come to a sudden stop without any cushioning, even a fall from just 1.7 meters can be perilous. The neck bone will be fractured, which means that even if you don't go fast, it is dangerous to stop suddenly, so you want to jump from a height safely. Bend your legs to absorb the impact and spread the force using your limbs, distributing the energy. You could even enhance your bone strength by swapping them with carbon fiber, which can handle high pressure, instantly making you more resilient and improving your survival odds."